Today is day 4 of Magento Advent Calendar, and I will show you 4 practical examples of using dependency injection in Magento 2 and your modules. No theory overload, just Magento plain simple code that you can apply on your day-to-day development experience. Here is an example of a PHP class called info. This is, in terms of Magento, it's called a block, and it implements two methods, getMessage and getCurrentTimestamp, and these two methods are used in a template to render some information that's provided by these methods. And let's say I would like to inject a dependency to this info class and use this dependency within this class. For this to happen, I would add this dependency into construct method. In my example, it's a private logger interface that I assign to a variable logger, and then I can use this logger in one of my class methods. So in this example, I use info method to log additional message every time getMessage method is called. Behind the scenes, Magento 2 uses Object Manager in order to check what types of dependencies have to be injected in the class that is going to be created. It checks additional DI configuration, and based on this configuration, it creates classes that implements interfaces. And in order for Object Manager to know what class to create based on the interface we've provided, so as you can see, we don't use a class name, we use interface. It reads DI.xml configuration across the whole Magento application. It checks that there is a configuration that is responsible for this logger interface, and the preference for this logger interface is a PHP class that later Object Manager creates and passes to this info PHP class. So every time I would refresh a page, it would trigger this logger info information since it's rendered on a page, and a record into the debug.log file is added every time if the page is not cached. We trigger a getMessage method. So you don't need to worry about object creation, how to instantiate an object, what are the object's dependencies if you need to create logger. So the class is not responsible for creating new objects. It can rely on Object Manager within Magento in order for Object Manager to create an object and pass as a dependency to your class. So try to avoid using new and class name in order to create new objects. So this example is an example of a third-party interface and Magento implementation of this interface that is passed to the dependencies. Let's have a look how we can manage our dependencies if we have our own custom class and how we can do this. So here I have a controller example called show, and I have two dependencies. One dependency is from Magento, and second dependency is a custom dependency. It's a PHP class created within this module. The responsibility of this data provider class is to provide some value. In this case, it's just a simple plain string. So here in execute method, I create a new object of a JSON, and then I use data provider getValue to pass this value into the result object that will be retrieved from execute method. So here Magento Object Manager will check the class name and it will create new instance of this class name. It will pass this instance during show controller object creation. And as a result, when we navigate to this controller, we can see that hello from data provider is passed as a value to the JSON object we retrieved from our show custom controller. So the controller itself doesn't know how the data is generated. It just receives a data provider as a dependency, and that's the real power of dependency injection in Magento 2. Here is a bit more advanced example. It's a preference replacement. What it means is that, as I said, that Object Manager uses dependency injection configuration, and our custom module can have this di.xml file where it can provide a preference for a class or for an interface. Here is an example of an interface that exists within Magento, Magento Catalog API Product Repository interface, and with the help of preference, we can replace or redefine configuration for this product repository interface. So in Magento core module, there is a configuration that says that for product repository interface, it has to provide product repository from Magento Catalog module. However, in our module, we say that we are going to override for the entire system this product repository interface, and we will call MageMastery module model product repository PHP class that we've created in our custom module. And here is a implementation of this product repository that implements product repository interface from Magento Catalog API namespace. This implementation can be based on a fact that it can retrieve from a different storage, or it can save to a different storage, let's say NoSQL or something, or with additional capabilities that, again, outside of the tutorial. However, it's possible to create a custom version of interface implementation. So going back to our example, we have a preference for an interface and we provide a type of a class that we're going to create. And in a client class, here is an example of a client class. It's an action controller called product that expects product repository interface as a dependency. However, since we have this custom preference in our custom di.xml file, we would expect not the core Magento Catalog model product repository, but our custom that comes from our MageMastery model product repository. And if I go to the action controller, as we can see, the dependency is set to be product repository interface. However, we retrieve our MageMastery model product repository, and there is an interceptor, a suffix that is basically generated by a Magento application in order to provide this plugin capability. It's additional feature within Magento 2 applications that can be used for overriding or adding additional functionality to any class in Magento. So as we can see, we don't rely on our custom implementation of product repository. We just provide an interface and we use preference in order to say that we would like for all dependencies to retrieve our custom implementation. But you have to be careful with preference and overriding out-of-box interfaces, because it means that your class is going to be responsible for handling the entire system and providing products from a custom product repository. So in order to avoid this, what we can do, we can use so-called virtual type. It's a feature in Magento that allows to redefine or provide a custom version of an object based on configuration. So there is no need to create a custom PHP class in order to provide some custom configuration of that object that is based on a real PHP class. So here I have an example of such implementation. So instead of using preference, I can command preference, and I can say that for my single use case, single scenario, that is controller example product, I would like to pass my custom product repository PHP class that is located in MageMastery module. And instead of Magento Object Manager creating and providing my custom PHP class for entire system, it will just check the configuration for this controller. It will check that there is a custom annotation for the product repository argument that I have here in a construct method. And if and only if my custom class implements product repository interface, and it does implement product repository interface, it can create and pass that dependency, that configured object that is based on an existing PHP class. However, the class is not changed, the implementation is not changed, it's just configuration, and object creation part is configured based on a custom di.xml configuration. And it will pass to the product action controller, and we can see the result of the page that we will refresh and see that our product repository is retrieved the same way as we did with preference. So the virtual types are a clean and powerful DI technique in Magento 2. You keep the original class untouched and create modified version like in our example with controllers, and when needed to avoid unnecessary preferences like in the example I showed you. These were 4 practical ways to use dependency injection in Magento 2. So we injected services, injected custom models, replacing implementations, and using virtual types. Tomorrow is day 5 of Magento Advent Calendar. Subscribe to not miss it. See you in the next video. Bye.